Welcome back everybody. This is our third class in JEE Mains previous year questions for chapter Moving Charges and Magnetism of class 12th. Before this, in this series, we have made two videos, and all those videos are available on our YouTube channel's playlist section. We have also started similar series for NEET previous years. So if some of your friends are preparing for NEET, then you can guide them to that relevant playlist. Also, if you find these videos useful, then do press the like button, share them as much as possible, and subscribe to our channel. It helps a lot when you share and subscribe. And if you want to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Even a small donation will be highly appreciated. So with this, let's start today's video, and I think we are covered up to around 15, sorry. This was the last question, I think, which we covered in previous video, and today we will go further. Let me adjust pen thickness slightly. Okay, so consider a thin metallic sheet perpendicular to plane of paper moving in this with speed v in uniform magnetic field going into the plane of paper. So here magnetic field is going into the plane of paper. Let's plot our first coordinate system and slide it slightly here so that we can visualize things correctly. So our screen is in XY plane and out of screen is Z axis. So here magnetic field is into the screen, means into negative Z axis. So we can say B node times K with negative sign. This is our magnetic field. And that sheet is moving with velocity V, and as per the diagram it is moving upward in this plane. So V is equal to V node, we can say, into J. So that's how we have velocity. So if charge densities are sigma 1, sigma 2 are induced. So here we are talking about induced charge. Note the any charge we have given to the plate. The charge is being induced on it, on left and right surfaces respectively then of the sheet. Then we have to find out values for these sigma 1 and sigma 2. Now, as we know that this sheet is a metallic sheet, and metals have free electrons in them. Now, when these free electrons moving through some magnetic field, then what will have? They will have a force acting on it, because we know that force acting on a charged particle in a magnetic field is given by Q V cross P, where Q is the charge, V is its velocity of the charged particle, and B is the magnetic field. Here, as sheet is moving upward, so those charges are also moving upward. So they also have the same velocity as the sheet. So now, as we have only electrons here, free electrons, so let's find out force on electrons. So force on electron will be, we will have a negative sign, and we are only discussing about the direction of the force, because we did not have to worry about the magnitude. There will be some magnitude, we only have to find out the direction. So direction of velocity is J, and direction of magnetic field is minus K. So now J cross K is I, so we will have negative I here, and if we have negative I here, this negative and negative will give us positive I. So direction of force will be positive. Means there are certain electrons in this metal sheet, and there will, when this metal sheet is moving upward, they will experience a force in the positive x direction. So our metal sheet will look like this. Suppose this is our metal sheet and it is moving upward with velocity v. Then the electron inside this metal sheet will experience a force in positive x direction. So what will they do? They will start, we can say, depositing on the this on the right side of this metal sheet. So all the electrons will start traveling here. So as a whole, this sheet on the right side will develop a negative charge, and as a whole sheet is neutral, so on the left side we will have as a whole net positive charge. So here on this side we have sigma 1 and on this side we have sigma 2. So from this we can say sigma 1 is due to positive charge and sigma 2 is due to negative charge. So sigma 1 will be positive and sigma 2 will be negative. So from that, option A get cancelled out and option D get cancelled out. Now coming to the value, that what will be the value of these sigmas. Now as mentioned in the question at starting, that it is a thin sheet, and for a thin sheet we know electric field outside of that thin sheet is given by sigma by 2 epsilon naught. And we also know that for a moving charge particle we can write this expression that V is equal to E by P. So using both of these, from this we will get E is equal to VB. Using this expression here, we will get VB is equal to sigma by 2 epsilon naught, and from this sigma comes out to be 2 epsilon naught VB. This will be the magnitude of sigma, and we have the signs already available with us. So sigma 1 will be positive of 2 epsilon naught VB and sigma 2 will be negative of 2 epsilon naught VB. Now we don't have any such option here. For that, it is possible that even after mentioning for thin sheet, they have solved for the thick sheet, and for thick sheet here we will not have 2. For thick sheet, electric field is given by, in case of thick sheet, electric field will be sigma by epsilon naught. And now using these whole expressions, what we will get, sigma is equal to epsilon naught VB. This is for thin sheet and this is for thick sheet. So our answer only matches for the thick sheet. So option B will be the right answer. Now moving to the next one. So a proton mass m accelerated by a potential difference V flies through a uniform transverse magnetic field B. The field occupies a region of space filled with D if alpha is the angle of deviation of the proton from the initial direction of motion. The value of sine alpha will be. So we have to find out value of sine alpha, and we have already solved this type of questions or this type of process. So first of all, here from the cross sign we can see that field is inward. So let's draw our coordinates. So we have x, y and z here, and B is, we can say, B naught times k, and it is inward, so negative sign here. Velocity we assume in x direction, so velocity is V naught times I, and as it is a alpha proton, it is a proton, so its charge will be positive. So now let's find out the direction of force acting on it. So force will be q. We are only talking about direction, so direction of v is I and direction of field is minus k. So I cross minus k, we know I cross k is minus j, so I cross minus k will be j, so we will have qj, or we can say force will be on the upward direction, or force will be in the y direction. Now after getting the direction, we know that when a charged particle enters in a magnetic field, it start moving in a circular path, and radius of that circular path is given by r is equal to mv by qb, and the point at which the particle enters in the circular path is act as a point of its circumference. Let me clear that for you, that suppose we have a region of magnetic field, we have this region of magnetic field, and here magnetic field is inside the paper, so magnetic field is closed, and we are talking about positive charge. And let's this thickness of this we can say this distance d, this distance is d, and this d is very large as compared to the radius of the charged particle which it will take after entering into the magnetic field. So what will happen? Suppose we have a charged particle entering from here. So when charged particle enters from here, what will happen? It will start rotating in a circular path, and it will keep on moving in circular path, and will come back outside like this. So the point at which the particle enters act as a point on the circumference of the circle, which particle will follow when it enters into the magnetic field, and some point in the between will act as a center of this we can say center of this circle. So this is the basic behavior. In some type of questions, what we have that this distance d is less compared to the radius, and in some question this distance d is larger compared to the radius. So it depends upon the type of question that what is provided, but according to the condition that d is greater or lesser, we have to make different we can say different assumption or different techniques to solve the question. Like in this question, it is shown that particle is escaping, means this d is smaller as compared to the radius, means we can say let me draw it again in a different manner. Now our d is something like this. The thickness here t, in the previous case it was square, so it was same for this one, this side and this side both were same. And in this case what we have, when particles enter and it start moving in a circular path, and here radius is greater than this thickness, so what will happen? Particle will not able to complete a complete circle or half of the circle, and eventually it will find itself in a region where is no magnetic field, and after that it will keep on moving on the straight path. And sometime it is asked that to find this angle alpha, where in this question it is also asked to find this angle alpha. So let us find out that angle using this same diagram, or let's redraw it. Let this red line represents the path of the particle inside the magnetic field, and after it escapes, it will follow path something like this. And we have to find out this angle alpha. Now, as this particle is, when it particle is moving inside the magnetic field, or we can say when it enters at point A and leaves at point B, it will be moving in a circle, and this circle is going to have some center. Now as we can see from the diagram, that from the top and bottom side, from the upper and lower side, this is infinite. So this sheet is infinite on the top and the bottom side. So center will lie inside this, or we can say this goes as like this beyond and on the negative infinity, something like this. So suppose center of the circle lies at this point, and this center is known as point O. So OA is also radius of the center, and OB is also radius of the center. And let me draw some lines here, that OB is radius and OA is also radius. And if we draw a line this here, and suppose it is C. Now suppose if this angle is alpha, when particles leave, then they leave at 90 degree from the center. So this angle is 90 degree. This whole angle is 90 degree. This angle is alpha, and let's extend this line here. So this angle will be 90 minus alpha. Opposite angle, this will be again 90 minus alpha, and this angle will again be alpha. So we have to find out value for this alpha or sine alpha. Now in this triangle, OCB, we have sine alpha is equal to, sine of alpha will be perpendicular by hypotenuse. Perpendicular is equal to CB and hypotenuse is equal to OB. Now CB is equal to thickness of this we can say region, that is D, and OB is equal to radius of the circle, and for charge particle moving in a circular orbit, radius is mv by qb. So it will be mv by qb. And here this v is velocity, so let me represent it smaller v. This small v is velocity here, and capital V, as you can see in the option, is the potential, because the proton was accelerated by a potential difference of capital V. So when we accelerate some charge particle with some potential, then it acquires some energy, and that energy is equal to kinetic energy, half mv square is equal to charge times the potential. And using this relation, we can find out that the value of V is 2 QV by M into under root. Now putting this value here in sine alpha, we will have Q d QB mass times what is happening here. Okay, mass times velocity, and that velocity is 2 QV by M. So we can write it like this. We have B here, and D we will have as it is. So B and D as it is. This M will go inside, and we will have 2 MQV. So BDQ divided by 2 MQV, and we can further write it like this, that BD, this Q also go inside a square, so it will be Q by 2mv. That is option D will be the right answer. Moving for the next one, A positive charge Q of mass m is moving along the positive x-axis. We wish to apply a uniform magnetic field for the time delta t so that charge reverses its direction, crossing the y-axis at a distance d. Then, so it is mentioned that we have to apply a field such that for time delta t so that charge reverse its direction, crossing the y-axis at distance t. So let me show you the diagram that how it will happen. So it is mentioned that we have a region or space where magnetic field is applied, and there is charge particle entering inside it. A charge particle enter inside it, and what happens to it, that it takes half rotation and it comes back with velocity in opposite direction. So if it is taking half rotation and coming back in the opposite direction, then means it has some point where it is center, and its we can say its radius, the distance, its radius is smaller than the thickness of this slab or thickness of the area where magnetic field is acting. And as per mentioned in the question, that this distance is equal to d, and here it is mentioned that so the charge reverses its direction, crossing y-axis at distance d, and this distance is the distance from the initial point of entry. So it enters at point O, so point A, and leaves at point B, and distance between A and B is equal to d. And we know that distance between O and A is equal to radius, and distance between O and B is also radius. So A and A to B distance will be twice of the radius, and it is equal to given as d. And we know radius is equal to mv by qp is equal to d, and from this we can find out value of magnetic field. B comes out to be 2mv by qt. So this will be the value of magnetic field, and from this option A get cancelled and option B get cancelled. We have only two options available, C and D. Now coming to the time, the time it took. Now time we can find out easily, that as it has traveled a distance of half the circumference. So distance traveled is pi r, and time will be given by distance by velocity. So pi r by velocity. And as the here we have we can say the answer is in terms of d. So we will use this relation, that r is equal to d by 2. So r is equal to d by 2. So it will be pi d by 2v. So pi d by 2v. Option C will be the right answer. Moving to the next one. A particle of charge 16 into 10 raised to power minus 16 coulomb moving with velocity along x-axis enter a region where magnetic field is along the y-axis and electric field along the z-axis, negative z-axis, negative and y. If the charge particle continues to travel along x-axis, the magnitude of P. So it is mentioned that particle is continue to travel along x-axis, means it is undeflected. And if particle is undeflected, then we have a relation that V is equal to E by P. And as here we have only find in the options we have only find out the magnitude, so we don't have to worry about the direction, just putting magnitude simply. Value of velocity is 10, value of electric field is 10 raised to power 4, and value of magnetic field we don't have. So B will be 10 raised to power 4 by 10, it will be 10 raised to power 3 Option 1 into 10 raised to power 3, option C will be the right answer. Moving to the next one. Proton, deuteron and alpha particle of same kinetic energy are moving in circular trajectory in a constant magnetic field. So magnetic field is constant. The radii of proton, deuteron, alpha particle are respectively. Which of the following relation is correct? So we have to compare the radiuses, and for that we have to form a formula. We know that radius is given by, for any charge particle, is mv by qb, where v is the velocity, not the potential, and they have the same kinetic energy. So mv is the momentum, or momentum we can write momentum and kinetic energy have a relation that it is given by twice m into kinetic energy divided by q by p. Now magnetic field is same for everybody, kinetic energy is same for everybody, 2 is constant, so we can say radius is proportional to root m by q. So now for let's first compare for alpha and we can say proton. So R of alpha will be proportional to mass of alpha, that is 4 times of the proton, and its charge is twice, because alpha particle has 4 times the mass of proton and twice the charge, and radius of proton will be proportional to its mass, that is m, and its charge, that is q. Now comparing both of these, R alpha by R of p, we will have root 4m by 2q, root m by q. So q get cancelled, root m get cancelled, and root of 4 is 2, and that is again get cancelled. So radius of alpha and proton are the same in this scenario. So we can say alpha and proton same, option C get cancelled, and proton's radius is lesser as compared to alpha, so option D get cancelled. So we have to do calculation only for the, now for the proton and deuteron. Now for the deuteron, we know that deuteron has twice the mass of the proton because it has an extra neutron. So mass becomes 2m and charge is same, that is q. Now comparing proton and deuteron, so Rp by Rd will be root m by q, root 2m by q, root m get cancelled, so Rp by Rd is equal to 1 by root 2, or radius of deuteron is root 2 times of radius of proton. So deuteron will have larger radius as compared to the proton, and proton's radius is equal to alpha particle. So we here we have, yes, option B, that deuteron has radius greater than proton and proton's radius is equal to alpha particle. Moving to the next one. This question has statement 1 and statement 2 of 4 choices given after the statement. Choose the one that best describes two statements. Statement 1. A charged particle is moving at right angle to the static magnetic field. So magnetic field is static, means it is not changing. During the motion, kinetic energy of the charge remain constant. So yes, as magnetic field or magnetic force does no work on the moving charge. And how you can find out that it is not doing any work? Because the force act perpendicular to velocity, and using that we can find out that power, that is F dot V, is equal to 0, and power is also equal to work upon time. So here work done by the magnetic force on the moving charge particle is 0. So if work done is 0, means there is no change in velocity. Yes, direction is changing, but in kinetic energy we have half mv square. Effectively it's speed square, speed square. So magnitude is not changing, direction is only changing, and in v square we have magnitude only, so it is constant. Now coming to the statement 2. Static magnetic field exert force on a moving charges in direction perpendicular to magnetic field. So yes, force is perpendicular to both. The force is given by Q times V cross B. So force is perpendicular to both velocity and magnetic field. So yes, 1 and 2 both are true, and 2 is the correct explanation for the 1. So option D will be the right answer here. Moving to the next one. Proton and deuteron both are accelerated through the same potential difference. Here we have same potential difference, and in one of the previous question we had the same energy. Both things are different slightly, and enters in a magnetic field perpendicular direction of the field. If the deuteron follows a path of radius r, assuming neutron and proton masses are nearly equal, the radius of the proton path. So here again we have to form a relation between radius and the variables. Basic relation for radius is mv by qp, and as both are accelerated through same potential, so we can find out that half mv square, where v is the velocity, small v is the velocity, is equal to q times the potential, that v, and from this velocity comes out to be 2 q v by m under root. Putting this value in the formula for the radius, so it will be mass times qb into 2q potential by mass, and we will have 1 by b as it is, twice mv by q. Now potential is same for everybody, for both proton and neutron. 2 is constant, magnetic field is constant, so we can say radius in this scenario is proportional to under root of mass by charge. Now for proton, radius of proton will be proportional to its mass and charge, assuming its mass is m, charge is q. And for the deuteron, it is proportional to, as mass of deuteron is twice, so twice m, and charge is same, so q. So we can say now radius of proton by radius of deuteron will be equal to root m root q root 2m by root q. Root m cancelled, q get cancelled, and we will have radius of proton by radius of deuteron is equal to 1 by root 2, and radius of deuteron is given as capital R. So it is capital R, so radius of proton becomes radius of deuteron by root 2 capital R by root 2. That is option B will be the right answer. Moving to the next one. Magnetic force acting on a charged particle of 2 microcoulomb in a magnetic field 2 Tesla in y direction when the particle velocity is. So we have to find out magnetic force. So charge is 2 into 10 raised to power minus 6 coulomb. Magnetic field is 2 Tesla in y direction, so J, and velocity is 2I plus 3J into 10 raised to power 6. So force is given by Q V cross B. As we have only one component in the magnetic field, so we can do simply normal cross product without using matrix method. So it will be 2 into 10 raised to power minus 6 into velocity, we have 10 raised to power 6, 2I plus 3J cross product with 2J. So this 10 raised to power 6 is adjusted with 10 raised to power minus 6, and we are only left with 2. So twice. Now going to the cross product. Now 2 into 2, 4, and I cross j is k, plus 3 into 2 is 6, and j cross j is 0, because they are in same direction. So it will be 8 times k, or 8 Newton in the positive z direction. So option A will be the right answer. Moving to the next one. The velocity of the certain ions that pass undeflected through electric field of 7.7 into 10 raised to power 3 volt per meter and magnetic field. So B is also given, that is 14 into 10 raised to power, we can say minus 2. And this we can say, so velocity, as we know the relation, that it is E by B. So 7.7 10 to the power 3 divided by 14 into 10 raised to power minus 2, it will be 1.12. So dividing 1.1 by 2, we will have, we can say it is 11 times 10 raised to power 2 into 10 raised to power 2 by 2, and it will be 5.5 into 10 raised to power 4, or 55 into 10 raised to power 3, 55 kilometer per second. Option C will be the right answer. Moving to the next one. An electric charge plus Q moves with velocity. Velocity is mentioned, electric field is mentioned, and B is mentioned. Y component of the force experienced by the charge is. So we have to find out Y component of the force experienced by the charge. Now here particle will have two type of forces. One is as it is charged particle, so it will experience electric force, that is QE, and it will also experience magnetic force as there is velocity and magnetic field. So we will calculate both of them separately and then we will combine them. So electric force will be Q times E, that is 3I plus J plus 2K. And as we have to only find out Y component, so here Y component will be Q. For the magnetic force, we use matrix method. Q times V cross B, I, J, K, 3, 4, 1, 3, 1, 2. So Q times I, 8 minus 1, so 7. And for J with negative sign, 6 minus 3. And for K, 3 minus 12. As we have to only find out J component, so it will be 3 minus 3J, or we can say J component here, magnetic force J component will be minus 3Q. So total force experienced by the particle in Y direction will be Q from here and minus 3Q from here. So we'll have minus 2Q, I think. Okay, we made a blunder here, that we took value for the electric field. Actually, we have to take value for the magnetic field. So it is 1, 1 minus 3. And now we will only calculate Y component to save the time. Let's delete this. So here Y component will be with negative sign, 3 into minus 3, so minus 9, and 1 into 1, minus 1. So it will be minus 10 into with minus already over there. So 10 Qj. So it is 10 times Q. So final answer will be 11 Q, and that is option A. So with this, we end this video here. Hopefully whatever we have covered here till now is helpful to you and understandable also. Again, if you have any doubts or suggestions, then you can put them in comment section. I will try to implement or solve. If you like this video and these videos, this playlist, then do share them, subscribe to our channel. Also, if you like to support us financially, you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Even a small amount will be highly appreciated. So with this, again, thanks for watching, and we will meet in next video.